Okay, we're going to graph this exponential function. I'm going to write the general form just above it so we can see what all the variables are. Because the first thing we want to do is graph just b to the x. So the a is the 2, the b is the 1.5, the h is 4, and k is -7. So before we look at a, h, and k, we want to make a little table and graph b to the x, which is 1.5 to the x. Okay, so I made a table, and I'm going to plug in -2, -1, 0, 1, and 2 into 1.5 to the x. So I plug in -2, 1.5 to the -2, so I could just put that in the calculator. It's about 0.4 repeating. I really just need one decimal place. I'm just trying to get a point that I can graph. So then I would graph -2, 0.4. And then if I plug in -1, that means 1.5 to the -1st power, which is about 0.6 repeating. So -1.6. If I plug in 0, I get 1.5 to the 0 power. I know anything to the 0 power is just 1. So 0, 1, there's a point. And then 1.5 to the first, that's just 1.5. So 1, 1.5. And then 1.5 to the second power, which is about, it's 2.25. So I'm just going to put 2.3. Go over 2, up 2.3. All right, step 2. It's going to be now we want to multiply all of the y values that we just got by a, which is 2. So I'm just going to do that in the table. Actually, I'll write the step. Multiply the y values by 2. There we go. So 0.4 times 2 is about 0.8 repeating, because it was 0.4 repeating. So that means instead of my point at -2.4, I'm going to erase it and put it at -2.8, so it's just a little higher. Whoops. Make that a little better. -2.8, so it's almost at 1. And then if I multiply 0.6 times 2, about 1.2, so I'm going to erase the -1.6 and make it -1 and then a little bit above 1. If I multiply 1 times 2, that is 2. So I'm going to erase the point at 0, 1 and put it at 0, 2. And then 1.5 times 2 is 3. So I'm going to erase the point at 1.5 and put it at 1, 3. And then 2.3 times 2 is about 6. It's actually going to be 4.5 because the original number was 2.25. But I'll put 4.6. Just between 4 and 5. So I go over 2 and then up here. Just trying to get a sketch of what this graph looks like. And then finally, my last step is going to be, so step 3. I'm going to use the h and k to shift. So h is the horizontal shift. That means I'm going to go to the right 4. And then k is the vertical shift. I'm going to go down 7. So that means I'm going to go to each of these points one at a time and then just shift them, count over, right 4, down 7. So I'm going to start with the one furthest to the right. It doesn't really matter which one you start with. So this one that's at 2, the one all the way to the right, 2, 4.6. I'm just going to count over and shift it over. It'll be down here. And so I'm going to erase it as I go, just because then I'm going to have points everywhere. So now I'm going to do the next one at 1, 3. It's down here. There's that one. I'm going to do the point at negative 1, 1.2. Down here, and then my last one is about there. So I'm going to erase the old ones. And then since I shifted down 7, and now I originally had an asymptote on the x-axis, and now it's down here at negative 7. And then I'm going to connect the points. It's going to go up. It's a little hard on the iPad to get them just right, but it looks something like that. And the last thing I'm going to do is list the characteristics. I'm going to put D for domain. Range. So the domain is all real numbers from negative infinity to positive infinity. The range, all the y values on the graph are above negative 7, so negative 7 to positive infinity. I'm going to write the intercepts. The x-intercept for now, until we get to the end of the unit, for now we're just estimating on the graph. It looks like it's between 7 and 8. I'm going to put about 7.2. Looks a little closer to 7. And then the y-intercept, I actually want to plug in 0 into the original function and work it out. So 2 times 1.5 to the 0 minus 4 minus 7. And then I'm just going to type that in the calculator. So it's about negative 6.6. If I look at the graph, that looks right. It looks like it's between negative 6 and negative 7. And then the asymptote, so horizontal line at negative 7, and then the end behavior I'm going to write out. So the end behavior as x approaches positive infinity, that means as you go to the right, the function's going up. So f of x approaches positive infinity. It's going up on the right. And on the left side, which we write as x approaches negative infinity, the function on the left is getting closer and closer to the asymptote negative 7. So there's all our characteristics.